So let me respond to this question by going right here to the Power of Logic website and doing a demonstration. So I want to talk about truth tables, and I'm sure a lot of this makes sense from doing the reading, but let me just recap a couple things. First of all, the website here has started things out for us by setting up the truth table. Premise 1, right up here, separated by a comma from premise 2, and then the conclusion symbol, and the conclusion goes out here to the side. And also on the left, they've already done the truth value assignments. Now the goal over here is to establish all of the possible truth value combinations. And so it's not that difficult when you only have two atomic statements here. But just in case it wasn't perfectly clear, let me just mention quickly how you would do this if you had, say, 3 or more. Just start with the left row, far left row, and split the column. I should say column, not row. Half true and half false. And then the next one over, we'll take half of those and split them in half, and then the bottom half and split them in half. And then keep splitting them in half until you get to the far right column, which will be alternating at that point. The textbook gives you a formula. If you have any other questions about that, post and I'll respond to those. So let's fill out this truth table. So essentially what we're doing is we're taking these two atomic statements and saying, if in the world where this is true, then what would this bigger sentence? Notice this is a compound statement that says it's not the case that both S and not are. And let's just fill it out and then we'll talk more about it there. All right. Now notice what we've done here. I've made truth value assignments under several operations, really under all of the operations, but with regard to each premise, there's only one main operator. In this particular case, it's the negation for premise 1, which just means this. Whether this whole sentence is true or false in this scenario is going to depend on, after we work out the formula, what it comes down to under the main operator. So let's say, so over here, let's say this atomic statement stood for I ate spaghetti for lunch, and this atomic statement stood for, or that symbol stood for the atomic statement I ate rice for lunch. And in this world, think of each of these rows as possible worlds, possible scenarios. Now in the world where this is in fact the case, if somebody were to have uttered this sentence, it's not the case that he had both spaghetti for lunch and did not have rice for lunch. That person would have made a true statement. And if they had said not are, they would have made a false statement. And if they were concluding not S, they would have a false conclusion. So that's essentially the way the truth table is demonstrating all of the possible scenarios. These are the only possible states of affairs that there are. We've exhausted all of them. And so these are all of the possible combinations of truth values for the premises in the conclusion. So then here comes the big question. Given that validity by definition is this, when all of the premises are true, the conclusion is guaranteed to be true. We can check that here on this table because we've exhausted the possibilities. Here premise 1 is true, but premise 2 is false. So this row doesn't really matter because it's not surprising that we would get either a true or false conclusion based on an argument that has a false premise. So let's look at in this instance. False premise. This one doesn't matter either. This one has a true first premise, but a false second premise. It's only in line 4 in this particular instance that we get all true premises. And in fact, when all of the premises are true in this particular case, the conclusion is true as well. We might say it this way. It's impossible for the premises to all be true and the conclusion to be false. In this example, there's only one row where all the premises are true, and in that one row, the conclusion is true, so it's valid. There's plenty of times, though, where you'll come across truth tables where you'll have multiple rows with all true premises, and you have to check each one. It's not sufficient just to have one or most of the times where the conclusion is true, given that the premises are true. Validity requires that it always be that way, and so you would want to check them all. Now this particular question on the discussion board was asking, what if there's only one premise? Well, consider the definition. If all of the premises are true, the conclusion is guaranteed to be true as well. So if there's only one premise, you just check every time that premise is true, because that is all of the premises. Let's go ahead and complete it here on the Power of Logic website. We'll check our truth table here. It's always nice and affirming. Oh, it's not affirming. I made a mistake. Well, where did all my T's and F's go? I have too many truth values in row 1. Alright, let me go back here and check. Row 1. Does it not like this? This is probably the problem. Okay, good. Sorry, I make mistakes too, apparently. So now it's a little more affirming. Actually, it's not that affirming yet. It's still asking a question. Hopefully we'll get the positive affirmation at the end. Alright, so basically the way the website is working now is it takes our truth table and it allows us to identify particular rows. It wants us to identify rows where all the premises are true. That's only occurring in the fourth. If it had been in others, we would need to check others as well. You can check more than one. And now the question is it valid or is it invalid? And we see that when all of the premises are true, the conclusion is always true in every one of those rows. So I'm going to say that it's valid. Can't have checked something. Oh, this is one of the quirks of the Power of Logic website. Apparently it only wants you to check rows. Maybe it would help if I read the instructions. You have asserted that the argument is valid, but you have also checked one or more rows. What did it say in that previous screen? Maybe I just need to read this more closely. Your truth table is correct. Now using the truth table to determine whether or not the argument is valid. If it is, click the button valid. If it's not, first check at least one row. Okay. Well, even whether you check the rows or not, that's where we need to be paying attention. Excellent. So if this is what you had done, you could just highlight this, copy it, and paste it into the submission area, and that would be sufficient for having done one truth table. Hope this helped. If there are any other questions, certainly just ask online, post another discussion board question, and I'll respond to those as soon as I can. Thanks.